could do this. Two, 15, 8. Boop. 100, 150, 175, 75. Then I want observed minus expected, get out of there, log squared. Is that the numbers you're getting for that column? Yeah. And then L4, I want it to be L3, observed minus expected squared, divided by E, which for me is in L2. You have to use this. No, you don't need to, but you can. So those numbers look familiar? What's up? I like it. And then, so how you guys feeling about that? This should feel very familiar. I know it's not the same kind of formula or the same kind of measurements, but it's still, I take each of these divided by their expected. That divided by this, that divided by this, that divided by this. The first time I sum anything up is to get the sum of all this stuff here. So if you want to sum all that stuff up, you can go to list, math, number 5. Oh shit, I forgot to get out of there, damn it. Stat, sum, list 4. Is that what you guys are getting? I get 82.99. Does that sound familiar? Oh shit. Let me know if you need some help. Or just accept your fate. Yes? I always like it when it's the calculator. What do you mean? Give you like 80 categories, so you could manage doing each row by hand. You don't have to use the list in the calculator, but it just makes it quicker. So what does that mean? If 0 means there's no difference at all, and the cutoff, I haven't looked at my cutoff yet. What's my cutoff chi-square score? Alpha's 0.01. Degrees of freedom. What's the degrees of freedom here? 3. I like it. They're not 499 degrees of freedom. There's 4 categories, so there's 3 degrees of freedom. What do you guys get for your chi-square?
11.345.
11.345. So the test is all like, ha ha, you gotta get this far away. And we're like, yeah. So 82 would be, somewhere over here on this wall, right? So what does that mean? What does that mean? What does that mean? What does it mean? So 0 would mean that what I saw and what I expected were exactly the same. That would be really strong evidence where, that's not enough evidence to say that they're different, but it actually is really strong evidence that they are the same. I mean, that's kind of crazy to get exactly the same amounts. So 0 means no difference. This is where the difference becomes big enough to say that there is a difference. So we kick this thing out the freaking, I don't know, I'm going to mix my metaphors. We kicked its ass. So have we found evidence that there's something different about these people's cholesterol levels? Hell yeah, totally, big time. Are they better or worse in general than we expected? Yeah, there are fewer with really high and more with really low. So this is sort of what happened in the 80s or 70s or whatever, whenever that Mediterranean craze came on and people were like, I must suck down a lot of olive oil. I don't know if you guys remember. Everybody thought olive oil was the answer. Oh, they eat olive oil in the Mediterranean. Their cholesterol levels are really low. Oh, God, they start drinking alcohol. Not really. There weren't. We didn't have olive oil parties. We're like, dude, oh my God, this is gross. But this is basically what happened. They could tell that it was different from what's expected. It didn't follow the general population, and in fact, it was much better than what you would expect. And this was true for several samples they took of people that lived in the region, right? And of course, it's more because they eat less manufactured bullshit. They eat more raw stuff. There's a big ton of things. But everybody went, olive oil is easy. Let me just start frying my fries in olive oil and I'll lose weight and have less cholesterol. Okay, so what do you say here? Yes, we have found evidence that they don't follow the general pattern. So I'm not making you do all 5 steps. I am making you try to read my writing, but I'm not going to make you do like all 5 steps of a regular hypothesis test. So let's do this. Let's do like a quick fire chi-square thing. Maybe someday I'll actually make a handout like this. Find the chi-square you would use in these situations. By the way, real quick, that little square is a part of the notation. It's not asking to be square rooted. It sort of doesn't make sense for this. Chi-square is a symbol. You can't square root it and have it mean anything. Not necessarily. But we're not going to. All right. So find chi-square. If I had 12 categories and alpha is 0.025. Any minute depends on work. I have 51 categories. Alpha is 0.005. Categories means degrees of freedom is 11. And then I want alpha to be 0.025. So I get 21.92. I like it. So that would be the benchmark. 51 categories. So I go to 50, and I want 0.005, which is the very last column. So I just go all the way over, and you get 79.490. How we do? I like it. Don't forget one thing I want to realize. Anybody freaked out about how big these numbers are getting? Because we're so used to the z-score chart. But remember, this is what I call the defining equation for this. It's really the most easily conceptually as to why it's shaped the way it is. But chi-squared follows the degrees of freedom. So as the degrees of freedom get bigger, chi-squared is going to be bigger because I'm multiplying by bigger and bigger and bigger. It makes sense. So as I go down the chart, these numbers are getting larger. And then finally, so now I get degrees of freedom for the last one. 3, and then I go to 0.10, and I get 6.25. All right, I want to do one more thing with this. Where are we at?
For the degrees of freedom.
8, yeah. And then what value of S represents P95? So what sample would have a standard deviation that would put it a bigger standard deviation than 95% of everybody else in this situation? Okay. So let me ask you, so if I had a sample that had a standard deviation of exactly 23, that's like P50. That's kind of like the bar, and so it's like 50% above and below. So now I'm just saying, so if I draw this picture, P95, of course, is going to be where? Down here, up there, in the middle?
To the right.
It's got to be way up here, because how much is it supposed to have down here?
95%.
95%. I like it. So how much should be up here?
5%.
Everybody with me? So I know this formula, which is how, oh, it's not my phone, somebody else's. Sorry. So what do I know already? So I'm trying to find a value of S, right? What do I know? I know n minus 1. I know sigma. And I can look up chi-squared. Can you? How do you find chi-squared? Degrees of freedom of 8. Alpha is 0.05. Do you guys see that? Because that chart's all about to the right. And again, that sucks, I know, because Z-score is all about to the left. This chart's all about to the right. Too bad. So can you look up this value here? 8 degrees of freedom. P95 means 5% above it. So just stop at 8. Bam. You guys get that? 15507? I mean, this isn't any different from the 3 we just did, right? What we're doing right now. P95 means this, so alpha's 0.05. And then yes.
What do you subtract one?
Say again?
What do you subtract one from this then?
When I go to plug it in, right?
Okay.
Right now I'm just figuring out what this is. Why do I need this? I'm trying to solve for S. I know this, and if I knew this, I could solve for S.
So when you find the degrees of freedom, you don't look at 7, you look at
Well, I told you the degrees of freedom is, I'm sorry, I'm being silly. Thank you. Degrees of freedom is already 8, so what's N?
9.
9. I kind of changed it halfway through how I was going to do this. So yeah, you're right. So what you go here? 8. Because I already told you the degrees of freedom is 8. This I'm trying to solve for. I know this. And now if I knew what chi-square was, I could solve for S, right? So what do we get for chi-square? We got 8 degrees of freedom. Did I look at the wrong place? No. Here's 8 degrees of freedom, 15.507 for 5%, right? So I just plugged it in. I can solve for S. So if I do 15.507, do a little algebra, make it 15, Jeff. Times the bottom 23 squared divided by 8. That's S squared. Right? Is that cool? Multiply by 23 squared, divide by 8. That's S squared. So then I can just do what? So again, if I multiply by 23 squared,
Square root.
divided by 8, that's S squared. Then I square root and I get my answer. Square root of that. $32. So I expect any sample I take, my best guess for what the standard deviation is going to be is 23. Because that's what the standard deviation of everything is. But if I got a sample that had a standard deviation of 32.022, then that would put it into the top 5%. It would put it into the 95th percentile. It's one of the more varied samples that I could take. "95% of other samples would have standard deviations less than 32.022. So it's one of the more varied ones. Okay. All right. Now it's sort of anything out even above that would be unusually spread out. Do you see how this starts to connect with stuff we were doing before? Maybe. Okay. All right. That's just one other application of this stuff. Can't remember. Somebody have the little homework sheet? I gave all mine away, and then I don't want to look it up. Your homework sheet,
Oh, like.
the one that lists all the
lists
homework.
it?
Yeah.
Yeah.
What's the last section I put on there?
11.6.
Yeah. Okay. I'm gonna make that extra credit. 11.6 is the section that does hypothesis tests on standard deviations, right? And I personally think that you guys deserve a little break from that. But if you want to do it, it's exactly the same steps. It's kind of nifty. You can do that for extra credit.
You said section 10 description for it. Is that one?
10-2. Yeah, it's on the time. It's on the homework sheet, so you can do that for extra credit also. I feel like there was. Oh, okay. So what I want to do now is I want to leave some time at the end here just to see if anybody was interested in getting an early start on reviewing. Tomorrow I'm going to have some. I'm going to have the answer key for the practice final. I'm going to have a few other handouts that we're going to kind of work on together to get some stuff solidified. But considering that the final is Wednesday, and we have to review everything from the entire semester, what I normally try to do is kind of like work backwards a bit, right? Because then that kind of connects it in our brains, because we remember the more recent stuff better. If I ask you right now to identify if a variable was interval, ordinal, nominal, ratio, you might be like, what?
I think I remember.
Huh?
I think I remember.
Kick ass. It's only the only nice thing about a 4-week course is it was only 4 weeks ago instead of 16 weeks ago when you take the final in a 16-week course, right? We did that just 16 weeks ago, guys. Come on. But there's also a ton of information that I shoved in your brains between that and now. So I don't know. We could do another example of the goodness of fit, because that's the one I'm really going to focus on. There's one on the practice final. We could do some hypothesis tests that we would see on there. Whatever you guys want to look at. Somebody has a homework question from one of those or something? Or if you just want me to make something up. Yes? Yeah, okay, let's do one more goodness of fit problem. And then maybe we'll do some hypothesis test stuff. So let's say no idea why this came to mind. No idea. I don't even like fish. So let's say we believe the number of fish caught at different lakes is uniformly distributed. So let's see. Let's say I have, so these are the lakes. Lake 1, Lake B, Lake Tom, Lake, Crystal Lake. There you go.
Lake Queen.
Okay, Lake Cuimaca. How would you spell that? Lake. I'll teach you Cuimaca, so I don't have to spell it. Lake, Land O'Lakes, Lake Lands. We got Lake of Dreams. All right, how many? That's plenty.
Lake of Fire.
Lake of Fire, I like it. That's the last one. Lake of Fire. Okay, so let's say that we observe this. We observe 11 fish caught there, 7 fish there, 9 fish there, 5, 12, 13, 10, 8.
37.
No. 4. Appreciate the suggestion. Is everybody with me on this? This is kind of a silly one, but I want to. It's just the first thing that came to mind. I normally want to use my third thing that comes to mind, but I don't want. Can anybody help me out with this column? You have what you need to be able to figure that column out. I was not careful at all on the numbers I picked. So let's see what happens. How do you figure out what goes in that column? All right, how many lakes are there? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So there's 9 lakes, 9 categories. Okay. So the number of fish caught. The number of fish caught divided by 9, because each one's going to get the same amount. That's the prediction I'm making, the claim I'm making. So what does this all add to be?
This is uniform industry.
I was so close to Ken coming out something nice.
That's what we do.
I think it adds up to 79.
Yeah.
Is that right? So then what's 79 divided by 9?
8.78.
Roughly?
Yeah.
Okay. So 8.7, go out one more place. 8.7,
70.
8.778?
Yeah.
Okay. We stop there. So unfortunately, now when I give you one on the test or something, I'm going to make it so it comes out to a whole number so it doesn't freak anybody out, but it doesn't have to. Why is this okay, by the way? Does this mean that we expect Lake 1 to have 8.778 fish caught? Because that would mean we were insane, and we might be insane, but not because of that. That's an expected amount. That's an average, right? So that's fine. It can be whatever it needs to be. All right, so now we can put all this stuff into our calculator. If you want to. This one's got a lot of categories. I would want to do it this way instead. Appreciate the no holding back on how we feel. So let's see. 11, just put all this stuff in there. 9, 5, 12, 13, 10, 8, 4. What's up? Did I? 7, 9, 5, 12.
No, I didn't.
You did, okay. That's your problem. Alright. And then 8.77. And watch what I can do here. Now watch. I can just put in there 79 divided by 9 so that I'm not rounding as much. 79 divided by 9. Unfortunately, this is not like Excel where I could just tell it to copy. I think I could tell it. No. What happens if I do this? It'll probably give me too much. It'll fill the whole thing up. Nah, shit. Yeah, it doesn't let me. It won't let me put that in there. Oh shit, and then I lost everything. Boy, Jeff.
Could you like store it and then just keep pressing like anything?
Not really. I don't believe so. Take it, Jeff. Okay, there we go. And now, of course, I'm going to be very, very nice on these. I will give you, yeah, this is data entry. You don't have to worry about it if you're watching this. I will give you this heading and this heading. So on one level, it's like, you know, just being able to fill this shit in is not very impressive because I'm telling you what to put there. So if you make mistakes there, that's bad. So here I want it to be L1 minus L2 squared. Observed minus expected squared. Bam! I'm not going to copy this up here. Too bad. And then I want this one to be all those, each of those divided by their expected values. And there's my expected values in L2. Get out of there, Jeff. There we go, buddy. Bam! By the way, if you notice, I'm first focusing on figuring out like our chi-square star, you know, our chi-squared. I need to also then go back and tell you what alpha is and all kind of shit. We'll do that in a minute. So how do I get what chi-squared is? Going back to you. How do I get what chi-squared is? What do I do? Just sum up L4, right? That's the formula for chi-squares, the sum of all that stuff, so I can quit. To be honest, I do this. So I I do one var stats on L4. The reason I don't like showing that too often is people look at all, and the only thing I care about is they sum up to be this. So if instead you do list, math, sum, L4, yeah, they're L3, L4, you're gonna get to the same thing I just got. Right, either way, I don't care. This one just only gives you that. The other way gives you a lot of other stuff that don't mean shit for this problem. So you get 8.608. So I know how far our sample made it. Now I kind of go back and figure out what was the benchmark. So let's say that alpha's 0.025. What's my degrees of freedom? Degrees of freedom. 8. One less than the number of categories. So can you find the critical score where the rejection region starts? So I get this. No, yes. Yes, no. Maybe. No. I don't believe it. So my critical score was 17 point, where'd it go? 535, is that the? Ooh, you're good. Yeah?
So in this one, you gave us the alpha of 22. Okay.
Yeah.
Just wanted to make sure.
I'd have to give it to you earlier. I just was holding on to it until now.
I was messing with my calculator and then I kind of looked up.
So notice what I'm doing for you on these problems. I am cutting to the chase. What are the two most important steps in any test of any claim? How far away does evidence start and how far away did you get? So obviously we failed, right? We didn't make it far enough away. We got to 8.608. So is that evidence that they're not uniformly distributed? We find evidence that they're not uniformly distributed. No, we didn't. We didn't succeed. So they could be uniformly distributed. We haven't found evidence that they're not. So we have not found evidence